now. Recording. Now I'm going to share my screen. Cha-ching. This is yesterday. Nope. That was yesterday. Any questions from yesterday that you would like me to do at the end of this lesson?
2D.
What did you say, Gavin?
2D.
And C.
2D and C. Anybody else?
I think
1C, please.
1B?
1B.
Sorry, you folks on the computer are really quiet for some reason. What did you say?
1C, please.
1C? Anybody else?
2E.
Sorry?
2E.
2E? Anybody else?
No.
Okay, it's super quiet. I don't know why. I think it has something to do with me mirroring. You know, just for fun, I'm going to put the volume up here. See if that has any impact. Can somebody, Gavin, can you just say something? Say no.
No.
No, it's still quiet. Okay, thank you though. Okay, so we'll do that after. Today, applications. Who wrote this? Fired. I forgot to put my water bottle in the freezer yesterday.
Is that close?
Mm-hmm. You got that, sister. You're right. I'll explain kind of why I am not making a bunch of notes for this when we get to the end. Has everybody got this? Anybody still writing?
No.
Okay, so the thing is, it's going to talk about how logs, in these pages, it's going to talk about how logs are used for compound interest, the Richter scale, pH, like acidity, basic levels, and decibels. They're all on kind of base 10 scales, logarithmic scales. It could be tons of notes or almost none. I could make the argument that on like the provincial exam, if you were going to write it, you could all of a sudden be given like a question about decibels or Richter scale or something like this without any prior exposure to a question like that. But if you know your logs well, then you'll be fine. So it's not like as you go through this, you don't have to memorize you know, the Richter scale or pH balance and any of that stuff. It's just a familiarity so that when you see it, you go, okay, no, I've done this before. Because if you were to get like a Richter scale question on an exam, it'll say, this is the formula. What is what is the earthquake in Mexico or whatever, you know what I mean? Like it'll give you the formula. It's not like you have to memorize any of this. It's just a familiarity thing. Does that make sense?
Yep.
Yep. It's so quiet. Okay, is what it is. So that's all I'm going to do with today's lesson. Like you have the whole class. There's also lots of questions. I'm here to ask questions. Remember, tomorrow we're starting at 10 in the morning. If you can make it. If not, that's totally cool. But that's, I don't want to say 9 just in case, because that doctor goes late often. So I will log in at 10 to kind of answer questions and stuff. And then, yeah, throughout the day, you got questions, I'll get to them when I can. And even the weekend, just don't like if you have a question Sunday night at 8 and I don't answer, don't get upset, because I will check, but I'm not going to live with my, well, I will live with my computer, but anyways, you get what I'm saying. So that's all I'm going to say about today, unless there's any questions or anything.
No.
Nope. Okay, so then let's do these examples or questions, sorry, that people wanted. Wrong way. Still so dark, but at least you can see this well. How far do I have to here? Okay, here we go. Page 252, 1B. X to the third, 3x to the fourth. Equals 12th root of 27x to the 7. Oops, 27x to the 7. Well, that's a whole lot of gross, eh? Okay, so I know on the screen you can't perfectly get all that, but well, there you can. I'll write bigger. Okay, so this is the more complicated. So this is what I'm going to mess around with. I want to get it here. That is ugly. We can combine these x's, and that'll probably be a decent place to start. So I'm going to first say x to the third times 3 to the fourth and x to the fourth. So if I am x to the third times x to the fourth, I have to add the exponents. 1/3 plus 1/4. So if I'm doing all my steps, x to the common denominator there would be 12. So 4 over 12 times 3 to the fourth, and x is 3 over 12. Does that make sense? I need the common denominator. So it's going to be 3 to the quarter, x to the 7/12. So x to the 7/12, we're done with the x, right? Because right here, that's x to the 7/12. So I need to figure out that 27. It's going to be 27 to the 12th. So this is tricky. Normally we have a bigger number like 27. We want to go, okay, let's go base 3. Here we have 3. We want to go base 27. So what that means, see if you follow me here, 27. Oops, that's off the board for our homies. Get it? Okay. 27 equals 3 cubed, which also means the cube root of 27 equals 3. Therefore, 3 to the third equals
27.
or yeah, sorry, 27. Yeah, thank you. I was like, yeah, that's why my brain cramped. 27 to the third equals 3. So I am going to substitute 27 to the third in for the 3 here. So it's 27 to the third to the power 4, x to the 7 over 12. So that'll become 27 to the 12th, 27 to the 1/12, x to the 7/12. They're both to the 12th, so that can be the 12th root. I can hear like almost everybody I know, I hate math. Like any of my like friends, this is a tricky one. Okay. And just so you guys know, those of you at home, because for whatever reason it's not, the volume isn't coming up super well. Yell, or I'll glance to see if there's a chat bubble or something. It might be better to text it. Sorry, I don't know why it's so terrible right now. But are there any questions at home?
No.
Okay. Yeah, like I could barely hear that. Can I erase this?
Go for it.
Anybody still need it?
Nope.
Okay. Thank you. You guys all here are all good? All right. 1B. 1C. What? Who assigned this? Actually, I like this stuff. So this is m to the x over 4 times n to the 2x over 3. This is insane. Cubed, of course, all over m to the 3x over 2 to the negative 1/2 times n to the 3x over 4 squared, of course, equals m to the x n to the x over 2.
Oh, yeah. Obviously.
Right? Like, yes. This looks insane, but it's actually really straightforward. So this side is nice and simplified, so we don't even have to touch that. We're just going to work towards it. First thing I would do is just think of order of operations. First thing you do is whatever's inside the brackets. We can't simplify anything inside the brackets. Next is exponents. We got to reconcile this bad boy here, this here, this here. So that's what we're going to do. So I'm just going to rewrite it, but I'm going to take care of all those. So on top, it's m to the x over 4. Can you can hear me okay on the computer?
Yeah.
Can't hear you. N to the, okay, so this is just multiplying. So this is 2x over 3 times 3. The 3's are going to cancel. It becomes 6x over 3, so it becomes 2x. So n to the 2x. Over here, we're multiplying. It's going to be negative. That's okay for now. M to the negative 3x over 4. And this is 2 times 3x over 4, so that's 6x over 4, or 3x over 2, into the 3x over 2. Are we okay thus far? Now we're still following, like we've done everything we can there, so we can either multiply these together and then move on to dividing, or we can divide while they're kind of separate. Sometimes it's easier to kind of keep it that way, and really, for us to multiply horizontally, we just drop the brackets. So we don't really need to worry about that. And like I said, it's nice and separate. Let's deal with the m's and then the n's. M to a power divided by m to a power is this power, subtract this power. So it's m, I'll do the steps, m to the x over 4 minus, and that's a negative, minus negative 3x over 4. So that's the m. And then the n is 2x minus 3x over 2. x over 4 plus 3x over 4 is 4x over 4, which is just x. So that's m to the x. And 2x minus 3x over 2. We're doing like, where's the camera? 2x, 2, what? Yes, but I don't want to skip a step. This was new yesterday. Try brown. Everybody loves brown. It doesn't say the colors on them because this is a light brown. Oh, there's another brown in it? There's 3 different browns. Anyways, so 2x minus 3x over 2. We need a common denominator. So 4x over 2, oh, that's a rich brown, minus 3x over 2. That would equal, surprise, surprise, x over 2. Who wanted 1C? Was that Emma's voice?
Yep.
Yep. Does that make sense?
Yep. All good.
Anybody else? Questions? Everybody here's okay? All right, Emma, can I erase this?
Yes.
What's that?
Actually heard that.
Did you? Can you guys at home hear Mrs. Thiessen?
Yes, we can.
Yep.
For you, those of you in the room, Gavin said, yes, we can. Okay, 2 ABC, 2C. Log of 1 over bx. Is this the question you asked me yesterday, Karina?
No, it was E.
Okay. Somebody asked me this. Minus log bx. Who asked this one?
Me, I just not really sure what to do when you do a fraction in the base.
Okay, so this is one where you kind of lean on the excuse me, the rules. Where's the rules? Need like a paper clip or something to keep that page. Thanks, Mr. President. Okay, so this one, what is going to help us here?
You just put negative in front of the first one, and that makes it log B.
Well, okay, so let's look at it this way. Yeah, you know, I'm just going to kind of play because I don't see it right away, but I do know. I'm gonna look at this one. So this equals log b of x to the negative 1, which would equal log b of 1 over x. And then where do I go?
Do you do something with the? You might have to do something with both sides.
Yeah, you might. I remembered I did this yesterday, and now I'm blanking here. So put that negative, that makes it like that. Well, okay, I'm just riffing here. If I put a negative in front here, then I'd have to put it there to kind of cancel it. Yay, that does nothing for me.
I'm thinking, is there a way you can make the bases of the logs the same?
I was thinking about that too.
Which,
Like you can change,
on the right side, if you move the exponential form, then it would be 1/x equals b, right? Then you'd be able
It's b to the something equals 1/x.
Yeah, b to something.
And this would be 1/b to something equals x. Okay, let me, if we do, so going off of rule 5, the left would be log x over log 1/b, and then the right would be negative, well, the negative could be kind of the whole thing, log of x over log of b, but there's a negative. Which means down here, that negative could be, I'll do the whole step for it, log x over negative log b, because a negative is top, bottom, or middle, doesn't matter as long as it's only once. So here it can become the exponent. Log of x over log of b to the -1 is log of x over log of 1/b. So that's a really kind of long way around it, but so this was me trying and not working, so I went this route. Tricky, but it does it. And then you can go from here kind of backwards into this, like to bring it full circle, to bring it to where it was. So your next step for here is to go here. I don't remember who went. This is you?
Yeah.
Is that okay?
Yeah, it's-
Yeah, that's tricky. Had to kind of mess around with it. Any questions at home?
No.
I'm hearing nothing, so I'm assuming not. And is there any chat bubble? No. Okay, can I erase it? As I put my head in front of it. I hope you guys are okay on the other side of that screen, because I can't hear you.
Can you hear me now?
2 A B C D. Look how quick I did the alphabet. Oh, no, I lost the page. What page is all this on? 252. C? No, we just did C, right? D. Log b to the p equals x to the p. What? Log b to the p equals log b of x equals log b of x.
You missed. part.
Good, because I don't see anything up there that's good. Oh, x to the p. Good gracious. X to the p. Log b dx. Cool. This looks like another rule fiver.
We're gonna get these rules on the test.
Yeah. So log of x to the p over log of b to the p. Okay, yeah, I see where it's going. So then you can put the p in front. P, I don't know if it's a capital P or not, but p log of x over p log of b. The p's cancel.
LG isn't that a company?
Oh, sorry?
Isn't LG a company?
Yes, but that's log. It's just my g's are often lacking. So we got log of x over log of b, which can become log of bx.
Yeah, just like putting it back. into,
Yeah.
Like undoing.
Yeah, totally. We just had to get rid of those P's. Yeah. Whose question was that? Yours. I think Gavin had the same one. Gavin, are you good with that?
Yeah.
So quiet. Okay. Anybody else questions before I erase this? Trying to listen without blocking the view. All right. Can I erase this? You guys are good? Sorry. That was 2D. Now let's look at 2E. Oh, mama. Page 252. E. Oh, this one's easier than it looks. 1 over log 7x plus 1 over log 3x equals 1 over log 21x. Okay, so this is also rule 5, that when it's 1 over, these two get switched. So if we get rid of the fraction, it becomes log base x of 7 plus log base x of 3. And because it's adding, so it'll be log base x of 7 times 3. So log base x of 7 times 3, which is log x of 21. See where this is going? And then you put it back, 1 over log base 21 of x.
So when you take the log out of the denominator, the 7 and the x, which is
Yeah. Yeah, that's a direct application of that rule 5.
I just converted like both sides so that like the right side was log of x to 21 or whatever. And then I ended up dropping the logs in that time too. So it was just 21 each.
That's more of a verification than a proof. Okay, so
Couldn't you just go with the, since they're adding, yeah, never mind, that's totally what you did.
no worries.
That's all.
I don't remember who wanted this one. Was it here or somebody else? Who wanted this one?
Me, and it's good.
And you're good?
Yep.
Any other questions?
Nope.
I feel like I'm crouching beside my computer like I'm talking to people that are 3 centimeters tall or something. Okay, so that'll be the end of the recording. If you got questions, let me know. Yeah?
Yeah.
Okay, bye little people, little quiet people in my computer.